Alright guys, let's start this review with number 3. Okay, we're going to factor completely, so real quick, just remember your weapons. If you need further explanation on the weapons, check out the zooms. So these are factoring weapons or tools. You have 3 of them, and hopefully you're comfortable using them for the proper or the correct problem. So right off the bat, I know that 4, 16, and 15, nothing can divide all 3. They do not share a common variable, so there is no GCF. But I also know this is the quadratic pattern. I have an even power, then I have half of that power, which is 2, and then no variable at all. This is the ABC quadratic pattern. So there's my A, there's my B, and my C. Once I recognize that pattern, I know it's one of these. The way I choose is X method is your A value is 1. Snowflake method is your A value is not equal to 1. So if you look, my A value in this case is 4, therefore it's snowflake. 8 times C on the top, which is going to give me 4 times 15. That's 60. And then my B value is negative 16 on the bottom. We then put our A value here and here. So our A value is 4 and 4. And then we split up the variable n to the 4th. So instead of n to the 4th, it's n to the 2nd, n to the 2nd. Okay, now ask yourself what multiplies the 60, that adds up to negative 16, and all you people good at multiplication know it's going to be negative 10 and negative 6. Okay, so once we got that, let's reduce here. What can divide 4 and also negative 10? That's going to be 2. So I could divide by 2 or reduce by 2 here and here. So when I reduce, we get 2n squared. When I reduce here, we get negative 5. Okay. Now let's reduce on the other side. I could also reduce by 2 here, so I'm going to reduce by 2 or divide by 2. That's going to give me 2n squared on the top and negative 3 on the bottom. And we're done factoring. So now I just write this down into its factored form. 2n squared minus 5 from the left side. And then 2n squared minus 3 from the right side. And we're done. We're not solving or anything like that. We are just factoring. Okay? So we're done with that method, but then we got to check. Can I use another method? Again, this is the quadratic pattern. It's the A, B, the B's missing, but we got the C. So A, B is 0, and we got the C. I told you there's a shortcut to check if these actually factor further, and here's how you check it. Has to be a power of 2, or an even power. Has to have subtraction, which we do, so power of 2. Subtraction, and then this guy has to be a perfect square. Okay, that means I can square root him. So in other words, I can do this and it will give me a perfect answer. If it doesn't, then you cannot factor anymore. If it does, then you should try the factoring method of ABC again. Okay, so let's jump over here. Squared. Subtraction, which is good, cannot be addition. Addition eliminates it all right away. So squared, power of 2, subtraction, so far so good. But when I square root this, it is not a perfect square. Okay? And real quick, if you're not sure what a perfect square number is, so perfect square numbers are numbers that when you multiply it to itself gives you an answer. So 1 times 1 times 1 is 1. 1's a perfect square. 2 times 2 is 4. 4 is a perfect square. 3 times 3, 9. 9's a perfect square. 4 times 4, 16. 16's a perfect square. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. And the list goes on forever. So these are examples of perfect squares. So that means when you're going to try to factor again after you factored once, these numbers at the end should be one of these numbers, a perfect square. If they are, they probably might factor further using one of these methods here, diamond or snowflake. Okay, so always be aware of that. Let's jump into number 4. There is no GCF, but I have 1, 2, 3, 4 terms, which means right off the bat it's factored by grouping. So I'm going to split. I'm going to GCF here, and the GCF I have here is x squared. They both have the variable x, and the lowest powered is x squared. So my GCF, I'll put it on top here, GCF for this guy is x to the second. So that means I'm going to divide by x to the second. This leaves me with 1x plus 4. And then you always put your GCF multiplied in front, x squared. Okay, so that's how I got my GCF there. Now we're going to do the same thing here, GCF. Remember, when the first guy is negative, we want our GCF to be negative. Okay, so if you look, when you're doing factor by grouping, we have to have a GCF. So looking at the numbers, the only number that can divide 3 and 4 is 1. They do not have the same variable. So when there is no GCF at all, then you have to use the number 1 in this case. Negative 1 is the only thing we're going to use to divide 3 and 4. So when factor by grouping, you must find some type of GCF, in this case, even if it's the number 1. So it's negative because my first guy is negative, so I want to take a negative GCF, divide this out. This gives me positive 3x plus 4. That goes in parentheses, and then my GCF's negative 1. Now we regroup. So regroup them. And the way we can regroup is as long as these guys are the same, the parentheses guys are exactly the same, we're going to regroup. X squared minus 1 goes in its own group. And then the parentheses guys goes together in its own group. Okay, so that's factor by grouping, but again, we're not done. We got to check. We know this guy cannot be factored because he doesn't have the quadratic pattern. He doesn't have a power, even power here. So he's done. But this guy does have an even power, so let's check. Does he have subtraction? Yes. Is his number a perfect square? If you look at the list, or at least know how to get the list, the answer is yes, he does have a perfect square. So that means we got to use one of these methods here, okay? So if you recall, I'm going to rewrite him in the quadratic pattern. So my A value is here. My B value is missing because I don't have the single x or the half the x. So that's going to be a 0 B value, and my C value is 1. So if I rewrote this, it looks like x squared plus 0x minus 1. And we're going to use the x method. Here's my A, my B, and my C. Okay, and my x method looks like this. A times C is negative 1. My B value is 0. What multiplies a negative 1? That adds up to 0. That's easy. It's positive 1 and negative 1. So this factors into 2 parentheses. So we split the x, so that's x and x. 1, positive 1, and negative 1. So this guy got factored again, and it turned into this factor, and now we're going to bring this guy down. All right, so again, always check, can I factor further? Can I factor further? All right, let's try number 5. 5, basically, we're going to factor this guy first, then this guy, and then see if we could even factor some more. So we're going to go a little faster. So let's ignore this factor first, and let's just work on this guy. So there's no GCF here. He is the ABC pattern, and it's going to be diamond because my A value is 1. So A, B, C. And we're going to use diamond method because my A value is 1. So there's going to be A times C. So 1 times 30 is 30. And then my B value is negative 11. And we got to ask ourselves, what multiplies the positive 30 that adds up to negative 11? That's going to be negative 5 and negative 6. Two negatives multiply to make a positive. When you add two negatives together, they stay negative. Okay, so this is my template. X to the 4th gets split into x squared, x squared. We have negative 5 and negative 6. Before we move on, let's check. Does this qualify to factor using perfect squares? Again, using the ABC method or snowflake and diamond. But we got to check for our perfect squares here. Okay. So I do have a power of 2, so we got to check it. This is A. Our B is 0. Our C. So is our C value a perfect square? The answer is no. So this cannot be factored. This does have a power of 2. So here's my A. My B is 0. My C is 6. Is C a perfect square? And the answer is no. So these are completely factored. We're done with that. But now let's shoot over here. No GCF here, but it has 4 terms, which tells me this is factored by grouping. So we're going to split. Okay, split it, and we need a GCF for both of these guys. So let's look at the left side first. The GCF of 5 and negative 1 here. We can't use a number in this case, but they do have a common variable. So we pick the smaller power, which is x squared. So my GCF here is x squared. Now let's divide by x squared. Okay, this gives me 5x. So what happens here is x squared and x squared, they eliminate, which leaves you with just the 1 here. My GCF goes in front. That's factored. Now we go here. Remember, because my first number is negative, that means my GCF, whatever I take out, is going to be negative. All right, so 15 and 3, what's the biggest number that can divide 15 and also 3? Is 3. No variable in common, so negative 3 is my GCF. This gives me 5x minus 1 and negative 3. Our GCF goes in front. Now, to make sure we can regroup, check the parentheses. Are they identical? They are. So now I could just write my GCFs together. So regroup the GCFs together. That's going to be x squared minus 3. And then regroup the factors together in 1. Because they're identical, we could write them down as 1. And now let's check. Can I factor this? Again, it does have a power 2. So here's my A. My B is 0. My C is 3. But my 3 is not a perfect square number. Okay, so this is not factorable. We're done with him. This guy's not factorable because he doesn't have a power, an even power. So this is my final factored form. All right, so I'll let you go ahead and do number 6 on your own. You're just doing this method, multiply here, and then combine like terms. Okay, you can have 2 variables, so be careful there. Let's shoot over to number 9. We're going to find the zeros, which means we got to solve. Before we solve, we got to make sure it's equal to 0, remember. So my highest power is 2. To solve, I want to keep this guy positive, which he already is, which means everything has to move to his side. And the right side will now be 0. So I got to move this guy positive 2h over. So I move him, always move variables and stuff when you're just trying to move sides by adding or subtracting. What you do to one side, do to the other. The h will go with this h. So we're going to put it underneath this guy because they're like terms. So now I have 2h squared. I can actually combine these. This turns into negative 11h plus 5 equal to 0. Now, once we have it set equal to 0, step 2, if you recall, is I need to put this in factored form by factoring. So it does not have a GCF. It's going to be actually ABC pattern. And it's going to be snowflake because my A value is not 1. So let's go snowflake. A times C is 10. B is negative 11. The A value goes here, 2 and 2, and then we split the variable h squared, which is just h and h. Okay, well, multiplies to 10. That adds up to negative 11. So that's pretty simple. It's going to be negative 10 and negative 1. Okay, again, common mistakes is people struggle with the signs. Make sure your signs qualify both multiplication and addition. For example, negative 10 times negative 1 is positive 10. 2 negatives multiplied make a positive. Negative 10 plus negative 1 is negative 11. Okay? Reduce the left side if possible. So I can reduce by dividing both of these by 2. So I'm going to divide by 2 here. They reduce into 1h. This reduces into negative 5. On the right side, they cannot reduce. So now I'm going to put them in factored form. Remember, it's an equation, so it's still set equal to 0. So I have h minus 5 and 2h minus 1. Okay, they are factored completely. To solve, we've done this before. We're going to set each factor equal to 0. H minus 5 equal to 0. 2h minus 1 equal to 0. Let's solve here. We're going to add 5. H equals 5. And then we're going to subtract 1, or add 1, sorry. 2h equals 1, and then divide by 2. H equals 1/2. So I have 2 answers. Let's check if we should have 2 answers. You always check what was my highest power. It was a power of 2, which means I should have 2 solutions. And we're good there. All right, number 20. I'm going to do my best to explain it. It shouldn't be too difficult if you understand what we're doing, okay? So the key here is this. If you look at number 20, it says the area of this rectangle is this equation or this polynomial. So real quick, I want to explain something. The area formula for rectangles is equal to length times width. So we need to find the length times the width. And if I multiply them together, they should multiply together to give me this answer here, which is not a number answer we're used to. But if you think about it, I need to multiply two things together. We'll call it the length times the width, and it needs to equal that. Okay? So in other words, we know the answer, we just have to turn it back into multiplication. So we want to turn this back into multiplication. What I've always told you is anytime you turn something back into multiplication, that's called factoring. So what this problem is really asking us to do is, can we factor this? And if we can factor it, it turns it into multiplication, which we will now know the length and the width. And that's what part A is asking. What are the side lengths? What's my length? What's my width of this problem? So that's our job. We are going to factor. Okay? So let's take our area, 3x squared minus 5x minus 12. And let's factor it. We have GCF, we have snowflake, diamond, and factor by grouping. The one that's going to work here is because we know we don't have a GCF. You can see that right off the bat. The one that's going to work is snowflake. Okay, why? I have my A, B, C pattern. Okay, and my A value's not 1. It's something other than 1. That's snowflake. So A times C goes on top. That's going to be negative 36. B goes on the bottom. That's negative 5. Okay. So what we're asking ourselves is what multiplies to negative 36 that adds up to negative 5. Oops, I almost forgot. Before we do that, we got to put our A value in here. So our A value goes in here. So our A value is 3. And we split up the A value x, which is x squared. Now it's just x with x. Sorry about that. But now we ask a question. What multiplies to negative 36? That adds up to negative 5. If you know your multiplication tables, that's going to be negative 9 and positive 4. Negative 9 times 4, negative 36. Negative 9 plus 4, negative 5. Let's reduce here if possible. We can reduce by 3. This turns into 1x. This turns into negative 3. Here, we don't have to reduce. There's nothing to reduce. So I now know my factor form is going to be x minus 3. And this one's going to be 3x plus 4. We have just solved part A. What are the possible side lengths in terms of x for the rectangle? Here are the possible side lengths. Here's my length. Here's my width, or my width and my length. It really doesn't matter which one is which. Okay? So, in essence, we had to take our answer and turn it back into what it was multiplied to it, because area is length times width. It's a multiplication problem. Okay? All right, I will let you do number B. It says explain your answer and justify how you know that the side lengths you found are indeed possible lengths. Use sentence diagrams, show your work. So basically what it's asking you in B, can you plug in something for x here, do the math, and plug in that same number here and see if they come out to the same answer. Okay? All right, guys, I'm going to give you the check-in code and get you out of here. If you have any questions, stay on.